Okay, so the last two examples I gave you were pretty beefy. They all had an A value. They had vertical shift. They had horizontal shift for your vertex. There's a lot of things going on there. I figured I would make this one kind of wimpy because sometimes you do those super hard problems and then you don't know how to do the easy ones. So let's try an easy one. And I also want to point out to you that I am adding two different questions here, and you have this interval in which the domain is increasing and decreasing on your homework, so I want to make sure that we do a couple of examples with that on there. Okay, with all that being said, let's get to work. So what is the vertex? Ooh, trickster, right? Yeah. Oh, no, it's not. You got this. 1, 0. Now, why is the y value 0? Exactly, because there's nothing back there. You totally have this. And the x is always opposite, and we are in vertex form, so that's legit. Okay, what's the domain here? Yep, negative infinity to positive infinity, because it always is. What about that range? Yes, now why is this 0 to infinity? Tell me. Yes, that's exactly right, because the a value is a 1. It is positive. Because the a value is positive, you know it's going to go up like a U, and you go from the y value of the vertex, which is 0, to infinity. You guys are awesome. Okay, so we just talked about the a value, so what is it to graph? It's a 1. So basically, there is no change to the y, because 1 times 1 is still 1. 1 times 4 is 4. So when your a value is 1, you're not doing any vertical stretching or shrinking. If it's still positive, you don't have to worry about it reflecting over the x-axis. Basically, you just do a shift. And in this instance, it's going to be a 1 to the right. And we know it's to the right because it's opposite of what we think right there. So I'm going to start off going 1 to the right. And then, whenever I graph, I'm going to go over 1, up 1, and back 1, up 1. Then, remember, you always have to go back to the vertex, over 2, up 4, and back 2, up 4, and put points there. Then, there's your super amazing parabola. That's awesome, right? Cool. And notice, we really couldn't graph this one any faster than we've done the previous ones, and it was so much easier. So when you get into those hard ones, doing your x, y, and y chart is just as fast as when you do these easy ones. Cool. Now what does this last little part mean? The interval, the domain is increasing. What the crap is that? Remember, increasing and decreasing and constant. Yes. So if I'm looking at this value, so I'm putting this little dashed line here as my axis of symmetry. Whenever you follow your graph, so from left to right, you're following your graph, and whatever your pencil is doing, that is what you're doing, increasing, decreasing, or constant. So if I'm going left to right, what's this arrow doing? What motion's the arrow doing? Decreasing, yes. So I'm decreasing, and then what happens after I hit my vertex? What starts happening? Then you increase. Good. So really, always, what are we looking at? That stinking star of the show again, right? Yeah, we are. And this is called the domain. So you know it's your x values, and that's always what you use for increasing, decreasing, and constant anyway. It's just your tip in the problem that says your domain. So my domain is increasing. Now notice the word increasing from what to what? Yep, from 1 to infinity. Good. And the interval on which my domain is decreasing from negative infinity to 1. Good. And 1 is kind of the breaking point. And then it starts going the other direction. Good. But 1's still included, so you're good with that. All right. Any other questions? Because I'm talking about the interval. Yeah, I'm not just stating the domain because you know the x's can't repeat, those kinds of things, but because I'm just talking the interval, and then it picks it up at 1. So yeah, you were good. Good question. All right, let's do another one. All right, I decided to throw another crazy one in here on you, and I wanted to do another standard form so that you have that as practice. So always, very first thing we do is what? Find the vertex. Good for you. So my vertex for this problem, my h value is going to be negative b over 2a. So I get negative 12 over 2 times negative 3. So negative 12 over negative 6 is a positive 2. Then you plug that back in. Negative 3 times 2 squared plus 12 times 2 minus 8. So 2 squared is 4 times negative 3 is a negative 12 plus 24 minus 8. So f of 2 in this instance is going to be 4. So my vertex here is 2, 4. What's my domain? Yep, what it is every time. So the domain is nice because you know it's always negative to positive infinity. What about the range in this instance? How is my parabola looking? Is it my quadratic graphed up, or is it a hill where it's pointing down? Good job, it's a hill, it's pointing down. How do you know that? Exactly, because I have a negative a value. With that negative a value, I'm going from negative infinity up to 4. Good, and while I'm talking about my negative a value, I'm going to go ahead and put this negative 3 in. Notice, when we start these problems, I already have my x, y, new y chart written in here, and what do I automatically have in there? That plus or minus 1, 1, plus or minus 2, and 4. Those are standard in the x, y, new y chart. You don't have to come up with those numbers. You're not finding those anywhere. They are just part of my x, y, new y chart. Awesome. So let's keep going here. If I multiply now from my 1 times negative 3 will give me a negative 3. We know that's going to help me point down for my parabola, and it's going to be a vertical stretch, so it's going to make it more narrow. 4 times negative 3 is negative 12. Okay, let's start off with the star of our show again. It's our vertex. Our vertex is the star of our show. That's where we start our graph, up here at 2, 4. So I'm going to graph at 2, 4, and then I'm going to move on my graph over 1, down 3 on both sides, then back 1 and down 3 to make those points. That's where those points come from. So once they're on there, maybe let's count it up and make sure you understand. From the vertex, I go negative 1 because I'm at plus or minus 1. So I'm at negative 1 and down 3. Because if I'm looking at my graph, I have an x and a new y, and that's what you graph from. Okay, then it's always back to the vertex. I'm going to go over 2 and down 12. Now this one's nice because I'll be able to put the whole thing on there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool? And then to the other way, over 2 and down 12. So we have this point right here. And notice it is symmetric, back and forth. Now let's see if I could make a decent parabola here. Through the dots, a nice narrow graph, and what else do we know? It is super skinny because of that vertical stretch. Good, nice narrow graph. Now, how do we answer these last two questions? The interval of the domain is increasing and decreasing. If I'm going to put my finger on the graph and I'm going to go from left to right, what motion am I doing here? Increasing. And then once I hit my vertex, what motion am I doing? Decreasing. Good. So the interval from which my function is increasing is going to be from negative infinity all the way up to 2, because that's the domain, that's the x value, and then it's decreasing from 2 to infinity. Remember, the goal here is the fact that it's the domain, so you're always looking at where it breaks off here at your x value. So increasing up to 2, and then decreasing from 2 to infinity. awesome. Good luck graphing these quadratics. I know you're going to have a good time.